let's pretend like we were working on a problem where we had to find a halfway point of an awkward interval and then find the halfway points of those halfway points of that awkward interval. Basically break some strange interval into 4 equal pieces. And one way to do that is to really rely on fractions, which I know sounds crazy because we do try to avoid those like the plague. But the nice thing about fractions is it's really easy to take half of a fraction, because if you want to take half of a fraction, you just double its denominator. What do you mean, Mr. Depsic? I'll show you. Like if I had, for example, like 5 7s and I wanted to break that in half, dividing it in half is of course the same thing as multiplying it. Dividing it by 2 is the same as multiplying it by a half. I can legit just double the denominator, and I know this is half of this value, right? So that's a pretty easy thing to do. So here I am looking at an interval that's going from 0 to 2 pi over 3. That's pretty nasty. But let's just find the halfway point. That halfway point, smack dab right here, will be, well, from 0 to 2 pi over 3 we know is 2 pi over 3, and if I were to take half of that value and multiply it by a half, I would have a 2 pi over 6. Now for the moment I'm going to, well, if I can reduce that fraction, I'll reduce that fraction. Let's go ahead and reduce that fraction just plain old pi over 3. That's a good idea. I like that. Okay, cool. So that I know is going to be pi over 3. Maybe you're like, duh, I had that 20 minutes ago. Okay, fine, hot shot. What about this halfway point? Go from 0 to pi over 3. Half of that is half of pi over 3. I can just, again, just double that denominator and get a pi over 6. No problem. But this red one here, that I'm about to mark in red, here's kind of what becomes the sticky wicket. We got a problem there. So to find the halfway point between the blue and the black, it's rough. Unless, my friend, you start using fractions like smarty pants. What I'm going to do is I am going to rewrite all of these fractions with the same common denominator. And when I do that, you'll see a beautiful pattern unfold. So as I look at this green, blue, and black fraction, I can see the common denominator here is going to be 6, right? So the pi over 6 will stay as pi over 6. The pi over 3, to make that denominator 6, I have to double the bottom and the top. So that would be 2 pi over 6. I don't know what this red one's going to be yet. We'll figure that out in a second. And to make this guy be over 6, again, top and bottom, multiplied by 2, gives me 4 pi over 6. So what goes in here? Maybe you see it right away, maybe you don't. If you don't see it right away, tell your brain to ignore the pi's. And tell your brains to ignore the 6's. You know? The advantage of getting all the denominators the same is if you're looking for a pattern, you can ignore the denominator, you know it's going to be over 6. If they all have a pi in them, you can ignore the pi. So we're essentially looking at the pattern from the numbers 1, 2, I don't know what, and then 4. What goes in that blank? Whatever goes in that blank is going to go here, and then of course there's also a pi, and there's also a 6. So this red mark is 3 pi over 6. What we've done here is we've taken an awkward interval, 0 to 2 pi over 3. We cut it in half. We cut those halves in half. So we've broken that red interval into 4 equal pieces that'll match our quadrantial angles. Hope that makes some sense. Let's apply that to the crazy cosine function.